the long wait is over. Join us as we celebrate Science Month 2020 in a new normal way. Bolder, livelier, and more exciting interactive presentations prepared for you. This year, we will focus on skills upgrade among science teachers in conducting synchronous and asynchronous teaching with scientific concepts as the new approach.
Good day everyone, and I'm Ma'am Florencio, and today I'm going to demonstrate the proper use of some laboratory instruments. Are you ready? Let's start.
First, we have here the triple-beam balance. So it is used to determine the mass of an object. It was made by a German gymnast named Friedrich Ludwig Jahn. So what are the parts of the triple-beam balance? Let's start with this part. This is called the pan. This is where we put the objects that we're going to measure. Then we have here the beams. So we adjust the beams for us to get to know the mass of an object. And then the last one, the important part, is the pointer. Okay, so this determines if the triple-beam balance is calibrated or not. Okay, so first, let us try getting the mass of this 1 peso coin. So let us put the 1 peso coin in the pan. Then the next thing is that we're going to adjust the beams. Let us try adjusting the largest beam, which is located in the middle. It is important that the pointer is at 0. Okay, so let us adjust the largest beam. The pointer is far from 0. Okay, so let us return the largest beam and try now the middle size beam. So, back. The pointer is far from 0. Let's return it again. Now let's try the smallest beam in the middle. Adjust. Yes, we can see now the pointer is moving. Okay, there we have it. We're going to know if you're done if the pointer is at 0. That means it is already balanced. Based on the triple-beam balance, the mass of the 1 peso coin is 5.6 grams. Okay. Try getting the mass of this 1 peso coin. Let us now try getting the mass of a heavier object. We have here the padlock. Okay, so again, you have to put the padlock in the pan, the center, and then adjust the beams. Let's try first the heaviest or the largest in the middle. Okay, so let's try the others. Okay, so be patient in using the triple-beam balance because there are different factors that can affect your measurements. For example, there is this one. Okay, there you have it. The mass of the product is 251.5 grams. Okay, so we are done with P-putting balance, and that is how we use it in getting the mass of light object and a heavy object. Now for our next instrument, we have here a digital balance. So like the triple beam balance, it is also used to measure the mass of different objects. But since it's digital, it is more accurate. Okay, so how do we use a digital balance? We have here also the pan. This is where we put the different objects that we're going to measure. So let us turn it on and wait for it to be calibrated to 0. Okay. So our first object is the 1 peso coin. You simply have to put this in the middle of the pan and wait for the mass. Okay. So the mass of the 1 peso coin is 5.39 grams. Now let us try a heavier object. We have here again the padlock. Carefully remove the 1 peso coin. And then put the padlock in the middle of the pan. Again, before we put anything else in the digital balance, you have to wait for it to become 0. Okay, so waiting for the calibration. Okay, so the mass of the padlock is 251.54. And as we can observe, they have different measurements. Why are they different? Because the digital balance is more accurate than the triple beam balance. This laboratory instrument can determine the mass of an object up to its decimal points. Okay, and that's how we use a digital balance. So now we have here 3 different instruments used to measure the amount of liquid. Now remember that measuring the amount of liquid and measuring the mass of an object is different. In measuring the mass, we use the units grams or kilograms, while in measuring the liquid, we use the units liters or milliliters. Okay, so we have here the graduated cylinder. The graduated cylinder is used for measuring small amounts of liquid, and it can measure from 10 milliliters to 100 milliliters. Its parts are the base, the mouth, and the bumper. The bumper is used to avoid breaking of the graduated cylinder in case it fell down. So let us try measuring the volume of the liquid using the graduated cylinder. So we have here an example. So for us to know the measurement of the liquid inside the graduated cylinder, we have to view it in eye level. Okay, so now in reading the level of the liquid, we have the meniscus or the curved shape that we can see if we view it in our eye level. We have the upper meniscus and the lower meniscus. We are going to read the level of the liquid based on the lower meniscus. Now the lower meniscus is at 100 ml. Therefore, we can say that the volume of the liquid in the graduated cylinder is 100 ml. Our next instrument used for measuring liquid is called the beaker. While the graduated cylinder is used for small amounts of liquid, the beaker is used for larger amounts of liquid. Okay, so let us try reading the measurements using the beaker. Now, viewing the level of liquid in the beaker, you have again to be leveled with our eyes. Now, the liquid is at 100, therefore, the amount of liquid in the beaker is still 100 ml. Now, our third instrument used for measuring liquid is called the Erlenmeyer glass. This instrument is commonly used in mixing substances and it can measure from 50 ml to 200 ml of liquid. Now, let us try using the Erlenmeyer glass in measuring the liquid. Viewing the amount of liquid directly leveled with our eye, okay, the amount of liquid in the Erlenmeyer flask is 100 ml. Today, we learned how to use some of the laboratory instruments used for measuring the mass and measuring the volume. In measuring the mass, we have the triple beam balance and the digital balance. The difference is that the digital balance is more accurate than the triple beam balance. In measuring the liquid, we have the graduated cylinder, beaker, and the Erlenmeyer flask, used for small amounts, larger amounts, and used for mixing substances. I hope you learned something today. See you next time.